This is IBM Museum. This video is going to be on a topic I saw on the VCF, which is the Vintage Computer Federation forum, a few days ago. And I'm trying to kind of keep up with the topic and post a response quick enough. But it was someone that acquired a PS2 Mul 65SX, and they had some issues with the memory that was installed. And of course, on a prior video, we have the 55SX, and it's important for me to maintain a little bit of or describe the perspective that we have, and you'll see it when I go through and move the systems around later on as well. That behind me, I have the 55SX seen on its side, and then I've got a Mul 65 that's unopened behind it. And that's going to be a little bit of a unboxing video. I barely cracked the case before, but that has not had that case cover off in years. And we're going to see a kind of glimpse inside just to see the adapters that were in there. And I noticed that foam is in some bad shape. We'll see how that is together. But back to the topic. I was actually a little bit interested. On the 55SX video, we did deal with a little bit of aspect of the memory on that adapter board. And of course, shown up there at the top of those SIMMs being either, supported are either 1 megabyte or 2 megabyte SIMMs. And those are actually, I think, 85 nanosecond for that size of SIMM. And the error that the person on the VCF forum described was that they were getting a planar memory error and asking what it meant and things like that. And I've seen that error before. And so I kind of wanted to go over the main SIMM memory of that is on the 55SX and even that 65SX. I got curious of what I may have installed in there, just because of things. And I was curious. I did look a little bit earlier on the 55SX, so I'm kind of aware of it, I guess, as a prep for the video. But we'll look over that. And this leads back a little bit as well to the that PD, or presence detect, setting on a SIMM, how it shows to the system. And that can be size, as well as the speed of the SIMM. That's a critical factor because those systems are set to recognize certain speeds as well for the capacity of the SIMM. And I think I'm trying to remember when we ran the system information tool on the 25SX. I think that was the most helpful, that it told us what sort of SIMMs you could put on the system. And of course, that's helpful when you could run that utility and you have enough memory to run that on your system, and it's got a spot to add more. But you could get in a catch-22 that you're trying to figure out the appropriate memory that your system needs, what size, what capacity and speed SIMMs that it needs, without the ability to run a utility that on the system itself to say, hey, this system supports these modules. And that was rather unique. A lot of the other PS2s that we've ran the system information tool on, it hasn't told us that level of detail on those other systems. Just the 25SX was supported for that, and that was clearly written in the code for it to, at least that model, to report that. And we should see that with some other PS2s that we'll test later on. But we'll get started looking at the SIMMs of the 55SX and of that 65SX, just to see what detail we can learn. So let's get started with that. Okay, and for the 65SX, excuse me, the 55SX, it's in the front here. Of course, this the position of the SIMMs right now is a little bit low, as it were. But, of course, I removed that riser support brace. And the main SIMMs, planar memory, for the 55SX are right down here. And of course, you want to look through. Sometimes there's the thought of, really the PS2s, there can be concepts sometimes of matching or particular SIMMs installed in particular positions. And we may get into that with some other PS2s. These SIMMs are the same. They're both 4 megabyte modules. And I did, as I said, for prepping the video earlier, I did briefly pull them out. And I don't know if there might even be a way I can normally go through and, have the little Skycam camera that's over to my left to show a little bit more up close detail. Some of this writing, I mean, you guys can see the Kingston detail, and that's pretty good focus. This really kind of amazed me when I if I can hold it steady enough here, to when I first pulled it out, because I'll hold one out as I read the other one. And this actually has where it's a Kingston module, of course, so we can all see that in print. And then it's the KTM-4000, which generally means the memory capacity, the size of 4 megabytes. And then it's got /M70. And of course, they even have a revision number of A01 on it. And I don't know how really Kingston goes through memory revisions, but of course they're a big name in the memory game. But the M70 kind of struck me as unusual, because being Kingston generally notes that'd be for a Model 70. And I don't really know of on the Model 70 planar that it supports a 4 megabyte SIMM on it. I thought for even the last version, the AXX Model 70 that we've had out here on the bench before, we've got the 2 megabyte SIMMs that we've modified for that system, and it's got actually 4 slots. It's got more SIMM slots than the older Model 70s. So I don't know what they really mean by having that M70 on there. And as we saw earlier with when we had the L40SX up on the bench and opened up, it had Kingston modules in there as well that were showed it was for the L40SX. There were 8 megabyte modules. They had this higher physical notch in the middle that it would fit in the L40SX SIMM socket. And that's a general rule that, it started to get established from the 72 pin SIMMs and onward, especially later in the later DIMM memory that's common now, is that they were notched that keyway a certain way. If it didn't physically fit on your system, it was pretty much a guarantee it didn't work. And 30-pin SIMMs, you could generally, they didn't have any keyway on them, so you could put a incompatible SIMM module in there, and it, of course, it wouldn't work. I mean, IBM had a different pinout for their SIMMs too than the standard that was out there, and 72-pin SIMMs are a lot like that as well. That they're not necessarily physically different, except that notch, that center notch, being deeper in the case of like the systems like the L40SX and some other ones that were identical models, but not really physically separate for the 72-pin SIMM modules. That way, they had all the pins and notches arranged in the same position, and then they mainly told the system had to tell that SIMM apart from others by those PD. And here it's got those presence detect shunts, or that they short across the terminals, and in this case that has all four done that way. So this makes it into a module that clearly the 55SX recognizes for being a 4 megabyte module. Now, on the VCF forum topic, Louis Olin actually did go through and respond on that, and he gave a link. He looked up what memory was compatible for the 65SX, and by definition, as I explained, the 55SX are and 65SX are basically the desktop and the tower versions. So they're treated as being, the 65SX is just the tower version of the 55SX. So it has more slots, basically, more drive bays on it. It's just a larger system. But as far as the CPU and basic memory arrangement, even can be the same chipset, that is identical. So a SIMM that works on the main board of a 55SX will also work on the main board of a 65SX, is the thought. And generally they even have the same number of SIMM slots and things like that as well. And so Louis responded, and he talked about the 2 megabyte SIMMs being supported on the 55SX and 65SX. And these are 85 nanosecond. And then he also talked about I have to make sure I get one that I can, and it's better for small lettering again. Let's say I have my glasses on, then I have to make sure that the camera's even focused at some. And I realize that it may be even beyond the capabilities of the webcam I'm using to focus on some of that for a length of time. But the FRU that Louis Olin reported as being supported was this 82F3337. And it's even my intent that, I may have a portion later in the video. I don't know. I've still got to decide based on how we run through this. That I'd even rather replace these Kingston modules. And sometimes Kingston also got to the point where they had, of course, microchannel memory adapters. And they had these modules that would work on those. And they would give, if they knew a particular memory adapter that had SIMMs on it was able to do, worked on a specific system, or they intended for a particular system, they could have marked the SIMM that way as well. That you use that SIMM in equivalent clunk microchannel board for the Model 70. But I wanted to go through and even put on these modules, since they were the ones that I know were intended, that IBM intended for the 55SX and 65SX, thanks to Louis Olin's response, that I would take it back to being putting those modules on, using these double-sided modules for something else. And as I was saying, later on, I haven't decided on whether I would do a video capture maybe of the 55SX running with these modules installed, just to show that there's not any errors or anything like that. And I haven't tested it out. I'm just taking it on that Louis is reporting the right details there. And I found I had 4 of those modules, and that's great for going through and seeing what we have on the 65SX inside. And I have 2 modules for that if they're not otherwise that. And as I say, normally these work out really good. If you have the 2 4 megabyte modules on the system planar for both the 55SX and the 65SX, giving 8 megabyte of memory, and then having one of these nice adapters, a single adapter in there, and that's where you get the other 7 or 8 megabytes, depending on that version of the adapters we learned in that earlier video, to go to near capacity of what the system recognizes for extended memory. So I don't know how much I have to move these off the screen. We're going to move the 55SX out of the way for the moment. And I can't even remember if I spun. And again, the Model 65SX case, that's like that Model 80 case that we've seen, and also the Model 60, which we really haven't had on video quite yet. I've got a few Model 60s, and undoubtedly I'll pull them out at the appropriate times. And the Model 60 was based on the 286 CPU. 55SX, just like the 55SX and 65SX, were based on the 386SX CPU. And then the Model 80 is based on the 386DX CPUs. And that's what I was going to kind of look at. I saw that foam, and I don't even want to touch that gooey mess. You can see down here, this is a piece that's stuck on the bottom and even has a portion that's hanging just in free air. But that stick is enough on that bottom of the side panel, that enough to hold it in place. You could probably shake that and it wouldn't. And this foam is up here from the top edge of this baffle, where this baffle pulls in air from a particular direction, where it is pulled through that vent opening, and the side panel has vent holes as well. But you get a little bit of air as it goes through, and with the power supply fan pulling that air up and out of the system. And that's generally what you had with computers, is you have it pulls in air from a lower position, typically on the front of the system, and that air moves through the system in an upward motion, as it is, where heat rises, and the power supply of a computer pulls that air out of inside the case to blow it out the back of the computer. Now I don't know if any foam is really going to be left in here. I guess there is this. Yeah. And when I cracked open the side panel of this, and I just wanted to look a little bit, and I did see the comparable adapter that we'd gone over on the 55SX being present, and I didn't remember one of these systems I'd gone through, and I thought I'd done the that 1 megabyte trick at one point to limit the adapter to having 7 megabytes instead of 8 megabytes. But I had seen that adapter, and I'd also seen the system in some other condition, and this is a good comparison to the Model 80. And as I said, we'll get looking at the Model 60s later on. And it still has this sheet over here, like I saw with some of the my Model 80s. But that foam that was in there has come off, and undoubtedly is some of the bits and pieces that were on the bottom here. And other areas, we see that the diskette drive, there's only the A drive in there, there's not any B drive, doesn't have that back plane for the 40 pin edge connector. It's got the 34 pin connector diskette drive, and later on we'll get into, still that video is ahead of the internal diskette drives of PS2s. This actually has the carrier, and this is of course the same hard drive cage. And normally if you have one, see there's that black tar mess even on the edge of this drive carrier as well, from that foam as well. It's just, that stuff is just so nasty. And I really like that. That's the kind of the default Model 60, Model 65SX, Model 80 power header there. Now the 65SX, normally what it came from, and we can kind of see with this, I was trying to go through, I was saying this is the bay adapter. When they went through and you had the 3.5-inch drive, as they got more modern, they went through and had that carrier that was the modification, or what you put in to mount a 3.5-inch drive in that cage. And this is particular to this metal piece was particular to the and more often used on the higher end Model 80s as it came out, or that change came later on. And this is actually a SCSI hard drive. And so, as I was saying, the 65SX came with normally came with a SCSI adapter called the Tribble that IBM put in, and that was normally run in it was a 32-bit microchannel adapter, but it could also run in that 16-bit microchannel slot. And then they also put the XGA video in the systems as well, just for a little bit better performance video-wise. So hard drive and video performance trying to be improved. And this with the that edge connector for the SCSI cabling, that tells me that there was a SCSI adapter in here, and I'll have to put a Tribble back in here because I've noticed that it, and we're leaving that black tar just everywhere as we move that stuff around. It's just, but I noticed that the adapter is missing from slot number 8, that top slot. And let's disconnect this power lead as well. And you also see another fix here. And I remember this barely now of why I had, you say, why are there diskettes inside the system? And I don't know if I want to move these, but I guess I will. I can always put them back. And these are, looks like there's 2 diskettes. Okay. I'll have to see. Those are even blank. Those look pristine. Those look new. I'll have to see if there's data on those. Go through there and use them as diskettes. And what I may do now, I do have a spare 65SX planar. I've taken pictures of it, and I'll have the pictures of that planar in the video description as well, just so people can see what it looks like. But I put those diskettes there, wedged under between the drive cage and the SIMMs, because that top SIMM has broken latches, the plastic. So now you know IBM Museum. Beyond using duct tape to pin SIMMs in place, also just puts diskettes in his systems to put pressure on and hold SIMMs in place as well. And these are the same Kingston modules. That's interesting. I wonder if I worked on both those systems at the same time. I mean, they wouldn't have come from the factory that way, and I undoubtedly sourced those 2 different ways, assumably from different sources where I got them. The 55SX was supposed to be common, and I'd actually heard at one point that it was the most heavily produced PS2. And I don't know how true that is. But for being a small desktop format, probably so. And then the 65SX, for being the tower version, came out rather late in the game, and that's why IBM threw those extra adapters in there just to eke out a little bit better performance, being that it was a 386SX 16 megahertz CPU that was in there. And they didn't do some of the CPU modifications like I saw with the other, like the 55SX had. And they even had a later planar of the 55LS486, where that was undoubtedly, we'll see that later on video, where that was an upgrade to the 55SX, and that updated the system a little bit better and had a 46 SLC2 50 megahertz CPU in it. So it really added to the performance, had IDE connection to run a little bit newer drives and get away from those DBA ESDI drives. But IBM really never modified or had a itself for the 65SX planar, even though there were aftermarket planars and things like that you could get. They were normally viewed as being replacing the Model 80 planars, or for kind of a higher end. And I'll have to see how those tabs are and see what's busted there. And I can jokingly say I'll take a collection fund if anybody wants to give me donations for like a 3D printer setup where I can print some way of retaining these SIMMs, this top SIMM, other than going through and using diskette. And like I say, I'll probably go through with my spare planar. I may even swap out the planar of this system just so I have complete SIMM sockets and things like that. I won't change out these SIMMs at this time. I'm kind of almost going through a little bit more of a teardown to show you guys. And but I'd like to get the planar in there, and I'll have to look even at the replacement planar to see if it has latches in place, or maybe whether how easy it is to come up with some assembly. Otherwise, there's got to be something else. I don't know why I use diskettes. There has to be some other mechanical way I could do to hold that down a little bit better. And it does look like it has the retainers in a way, but so the SIMM is held in position, has to be released, at least on that one side. But it's sure not tight in there on that top one, just like the bottom one. And like I say, these things get brittle. And maybe this is as good a place as any. Let me get my glasses back on again. Because as we saw, at least we've got good examples of these Kingston modules that I pulled out of the 55SX. That all those, it's got shunts across all four positions of the PD. So these are all effectively closed. And I'll have to look at the chart and see capacity, what speed this is recognized as. The memory chips themselves are marked as 70 nanosecond, which I know is probably too fast ultimately for the needs of the 55SX. I doubt the system would recognize 70 nanosecond SIMMs in their what combinations they have for the presence detect. But also, Kingston could go through and they could make these modules and even be somewhat generic on what capacity of chips would go on these places as well. And then go through and silk screen them and have these PD locations, presence detect locations, filled in for what they wanted the module to be of what was there. So they could make this appear as a 70 nanosecond module of the 4 megabyte capacity simply by changing those presence detect bits as well, and then just silk screen the board a little bit better. And I also wanted to get out across, in physically looking over these SIMMs. You see the 8 chips on front, and then you have also these 4 chips on back, and recognizing that when you talk about PS2s, you're going to be referring to parity RAM modules. They're going to have a parity bit normally for the SIMMs on just about, I think, every PS2 that's out there. And that's just that extra bit. And normally these are treated as being so many bits by 36 wide, just to encompass those parity bits. And then there's, of course, later modules that are non-parity. And even when IBM got into like the Value Point series, where they had systems that didn't really have a parity bit that was needed with the memory, they chose to be a little bit more economical with that series. Those are so many bits by, depending on the capacity of the SIMM, by, it's marked as X32, 32 bits wide. And that's without any parity to it. And parity is just a way, I can't be going to a real long description, but it's just basically tracking the accuracy or making sure the contents of that RAM are valid. There's not any a parity error. And that's the other thing that you can get into. If you try and, put a SIMM into a PS2 that's non-parity, of course it's not going to work. But I wanted to look and compare these. I have, we talked about the 80 nanosecond, and these are marked as 4 megabyte 80 nanosecond, in addition to having that particular FRU on them. And I was looking to see, they do have some of these capacitors on top. These are actually capacitors for basically a power loader, just to buffer a little bit of the power reservoirs of the SIMM, that they just hold a little bit of a charge to keep the power levels on the SIMM relatively stable for the purpose of the memory chips. I don't know what this position here. I'm taking that the PD settings of the 4 settings are the 2 here and the 2 here, that are lateral to that, or the same position on either side, rather than this not necessarily being any sort of the PD setting on it for whatever component that is, whatever application. And then on this 80 nanosecond SIMM, it has all 4 populated. So Kingston, with its setup here, is basically mimicking what would be the presence detect of these boards as well. That's why it works on the system. And as a comparison, I have 4 megabyte 70 nanosecond modules. And these are almost the easiest. And I know the camera won't focus that small as well. I may need to do this video segment and gain this in my circuit board holder and get my camera to zoom in on them. But these are actually the most ideal presence detect for modifying sometimes, because it's actually a semi-ring and a circle on solder pads that you'd basically just fill in those positions with solder, or suck the solder off of there, remove it with the wick or whatever, clean the extra solder out of place, and choosing whether you have a shorted or an open bit of that presence detect. And looking at it with my glasses up close, or at least this one has, yeah, okay, good. So this SIMM here has those little solder pads. I could say that's really nice, because you don't even have to add a little wire to those to change the PD. You just work on with your soldering iron to get a solder blob in there. And it has the same setting. It's got closed, closed, open, closed. And then you can see this module has the same exact FRU. And this is a real common 4 megabyte module with the later model PS2s, and like the Model 90 or something like that. And it is has the real common part number 71F7010, and that being a 4 megabyte module. I think on the 8 megabyte module, it finished, the part number finishes with 7011 being the next level up, and that is the 8 megabyte module. But the point is that those closed, closed, open, closed, which shows really good up on that module for as long as we're in focus, that shows that those PD bits are set differently. This presence detect is open for that position, different from what the 80 nanoseconds. So these are both 4 megabyte modules, parity. They do have 9 chips in this design on the front, and being that ninth position is for the parity section, and otherwise similar chips there, but one is even one set for 70 nanosecond, one is set for 80 nanosecond. And undoubtedly, if you put a 70 nanosecond module into the 55SX or 65SX, it wouldn't run, even though the memory is faster. I mean, if you went through and you added on that PD bit for that one position, it would function perfectly on the system. The memory is faster than what the system needs, and so the board would function. But for this intent, it was used on higher level PS2s to say, hey, I'll function with a 70 nanosecond SIMM, but you know what? An 80 nanosecond SIMM is just too slow for me. So that's the reason that that those were set that way as well. Not that this module didn't work, but they had to, somewhere else, IBM had to go through and delineate it from the 80 nanosecond version. So we'll get into that and putting those SIMMs in at some later point when I figure out how I'm going to retain those in the in those slots, or whether I'm going to change out that. I just have to make sure that. And these are supposed to be thumb screws, although they can be rather tight. We may just have to deal with that one when we get down to there. I want to go through and show this a little bit more, because it's a lot more interesting to see this from this position, of course, rather than side view. You can't really tell what it is. But this is probably the AOX Incorporated, what they call the MicroMaster. And that microchannel is a bus that you could go through and conceivably add CPU functionality onto the bus. That processor on the system board could share processing capability with what an adapter had. And this is the 16-bit version here, even though it does have a 386DX CPU on there, and then even has the 387 floating point processor as well. So CPU and FPU, and then it's got RAM in there for the supporting that processor. And these are very desired cards because, like I say, they can go through, and they, of course, they have a setup and a configuration to make them work with the system, but they can improve. It's just like an upgrade CPU would be, instead of going through and having to work somehow with that 386SX to have some sort of clip over, because that's, a PLCC design. It's surface mounted effectively to the system planar, and they did make replacement or upgrade CPUs that were so-called clip overs, but there was a lot of issues to that, and also clearly the surrounding components we've got the floating point processor or coprocessor socket there, and that's actually filled in on this system too. So, you had surrounding components, and it was kind of hard. Even capacitors, it stuck up to a high level that it was hard upgrading these 386SX CPUs normally. And this is a 386DX 20 megahertz. And of course, the floating point coprocessor is also 20 megahertz. And I really need to put the Tribble back in place and get this drive to run and see, make sure I've got the setup to run this board on this unit. And it's got some IBM SIMMs in there as well. And these are probably and it's got where it's the 8 chips on front and the 4 on back, and who knows if this is something maybe like that, very similar to the Kingston modules. Effectively, or I'd have to go through and check to what these SIMMs are, and I think I have more of these as well. But yeah, this is a very coveted adapter. I'll have to make sure that I run it, and the label. And of course, as I mentioned, these came out. These were made by AOX Incorporated. Is the name of the company, and it has copyright dates of 1988, 1989 on here. I can even provide a link for this in the video description, but the label, and I don't know if that is going to be visible at all. And it says IBM internal use only. And so maybe that was the enhancement of the additional enhancement of the 65SX in this case, of having that board on there. Now we do, and I'll go through. We can probably remain organized. I doubt if I'll go through and put the diskettes back in there to hold down the SIMM. Who knows? As long as it doesn't fall out, and I'm aware of that, I don't try and power up the system or whatever. But I'll probably try and clean the foam and stuff like that out of there as well. Now we have the other end of the spectrum. It looks like that is that thumb screw. Yeah, thumb screw's loose enough in this case. And this adapter. And that's IBM token ring adapter. This is the short card. I mean, this is still a fairly good card comparable to other IBM token ring boards. They do have a silver cap chip in here. And there was recognized replacement levels and everything else for these token ring boards as well. That you had to make sure that you had a particular version. And I'll have to look up this board. But as I say, this is the short version, which should be a little bit better, a little bit more compact than the full length one. And IBM actually did define them as that, short and long cards. And this actually has the 2 EEPROMs on it. And an aside there were models that had the 3 EEPROM chips. And that third chip was for that Ripple process, remote initial program load. With these, that Ripple chip functionality is built into these 2. So when they reduced it from 3 EEPROMs to 2, you still had the ability to ripple from these adapters. And like I say, I'll look that up to find out. I think that's probably a relatively new token ring board. And it just has the initial token ring connector, which is a DB9 female. And then quick lesson on token ring. Let's make sure that is Although really the focus doesn't matter, because if you just have a straight green dot, that is 4 megabit token ring, the initial speed offering for token ring, and with numbers in there, and they have a 16/4, and that means that it's also able to do to function on a 16 megabit token ring network. And your token ring networks, I mean, they were the slowest device, or the first device that rang in on a token ring network. And I'll probably have a video on token ring, the concept later on of how it was matched up against Ethernet at the time. And of course, Ethernet truly won that game in the end, but it was more of a economical aspect of that VHS beating out Betamax, the Betamax format, just because it was cheaper to produce. But it's a real novel concept, but you can't have mixed devices. You can't have, in a token ring network, have some devices that are operating at the 4 megabit and some at 16 megabit. Your ring of the token ring has to be at one of those speeds that the adapters are capable of. So all the adapters on a 16 megabit token ring network have to be capable of that 16 megabit. And that's just a brief primer on token ring. And then I even probably have one of these in the car right now, because I'm going to send one to a guy takes the DB9 and goes to what they call a Type 1. That's a Type 1 cable that has a hermaphrodite cable on the end that you can have the same connector on either side, and it mates to itself. And who knows, when I go over the token ring stuff, I'll show that. And it's interesting, those terms, not necessarily being any sexual connotation, but being in use there. So let's avoid the controversy, I guess, is the way to say that. But yeah, we can go over token ring later on. And I don't know, I think this video is going to come out long enough. I don't think connecting up the 55SX and powering it up and seeing that those SIMMs run like they're supposed to. I've got enough trust in the parts that Lewis reported and what I had on hand. And see, this is, as we saw from that earlier video, it's got the nice back bracket, the nice metal SIMM latches, the upgraded EEPROM, and all these are 2 megabyte SIMMs. Yeah, still pulling foam off of me. I'll have to wash up, and I already even showered today. I tell you, getting that foam off. Once you have experience with that foam, it's nasty. We'll have a little thing on this later on as well. I mean to really look at this. It's been bugging me for a long time. And I think I mentioned it when we looked over this adapter. I mean, that's a Seiko Epson logo that's on that chip. And on the back, and again, we have the markings of the labels that IBM has stuck on there to show that this is an upgraded adapter version. Has all the newer EEPROM parts and everything else to make it that more desirable 85F0480 adapter. Instead of the other one's like 15F 8292 or something like that was the older version. But again, on the back, very prominent, we have that Seiko Epson logo, and even a unit number. They're marking it separately than what like an IBM adapter would be marked. And really, that's the interesting aside. I wonder what I call the Seco-Epson connection was to IBM, or leading that with the IBM Seco-Epson connection, of meaning that Seco-Epson produced various parts for IBM without really that being known on the outside, or what the relationship was between the companies of how they work together in that regard. And of course, Seco-Epson also, you'll see are marking a lot of time for, as this shows, it's got the Seco-Epson logo, and then it's got Japan immediately following it. I know, very hard to see again, but it's got, right after that logo, it has Japan. So very big name in the Japanese side. And there was things that IBM bought from Seco-Epson, like the so-called Super Twist displays, but they were saying that that was for the Japanese market. They didn't talk about that being, and what was the PS 55 series that was used in the Japanese market, not such a big thing in the US and European market. And that's even missing the battery as well. And since I've got those new batteries, it'll be maybe that'll be the thing to configure and run this thing on a later video, connecting it up and seeing what that leads to, even figuring out if this floppy drive diskette drive is functional at all. So that's a little bit of the overview of the 65SX. And it's kind of hard to see, of course, beneath that drive cage as well, but I'll have a link to where the picture, high resolution picture, is of that spare model 65 SX planar is, and the one that I may even swap into this case for as a repair for that SIMM socket. And this gooey mess has gotten all over the bench here, and I don't know how involved. This retainer looks like it's broken for retain the that's designed for, well, about that width of cable, that 50-pin cable. I don't know how much I want to really put this back together. Oh, and I have and a lot of this stuff loses its stick as well, these labels. This I just know from my interaction with PS2s. Wow, that's hard to get focused. But I know this is actually from the token ring adapter. And just by the recognition of the FRU. And I think that's a late model card. I think that's probably a good 16-bit microchannel token ring board to have in here. And we'll see later on with that token ring. I have a whole IBM bridge unit that I haven't showed yet or worked with since I got it, since I received it, for bridging token ring and Ethernet. And it's even a thought of getting a system with a token ring board, getting that connected into your regular network. There's some possibilities there. But that's all I have for now in going through things. I'm glad you were able to see me get into the system and get a little bit dirty. Looks like I was eating chocolate or some brownie with that tar on me. And if you did like this sort of teardown video, investigation of a system that I've had set aside and stored away for a few years, and looks like I stripped some components on it, and I just need to get it back together. We'll get it fired up on another video. But let me go on screen here. Okay, back on screen here. And if you do like this video, go ahead and click on that like button. Please subscribe to my channel if you haven't already. Invite your friends. I'm going to post a link to this video once I get it up on the VCF forum area that I was talking about, that particular thread. Maybe to be of help to that person to find the correct SIMMs for running in their 65SX. Get that to be a working system, just like I'm going to try to get this system that's behind me functioning correctly as well. And it's been a eventful journey as we saw the diskettes and everything else doing an unintended function. I thought that was kind of funny to stumble across what I had as an earlier solution for keeping a SIMM in place. And I promise, all I did earlier today was crack open the system a couple inches at the top just to peek inside. I was curious on what it had. Didn't even look at the back of the brackets. Normally that's not even real descriptive for microchannel adapters as well. A lot of time for a memory adapter or that AOX that don't have any connections on the back, that back bracket can be rather generic. It's used the same on all those systems. So I only had the idea that had that memory adapter at the bottom. I could see the SCSI adapter was missing. I could see the AOX board in there. And I saw, of course, the Bay adapter. That's kind of a good thing to go over sometimes as well. But I didn't get in there to know that the battery is missing, and that I even had a floating point processor in there, since that's tucked down their way on the planar, or any knowledge otherwise of that, what was holding those SIMMs in place. And so it it turned out to be that was the wart, I guess, for this video, or showed an aspect of it. But that's all I have for now. This is IBM Museum. Thank you.